This is the November 2011 Unit 1 paper, Statistics and Probability. You can use a calculator. Question 1 is a probability question. There are yellow discs, red discs, blue discs and green discs in a bag. Dinesh is going to take at random a disc from the bag. The table shows each of the probabilities that Dinesh will take a red disc, or a blue disc, or a green disc. Work out the probability he will take a yellow disc. Now probabilities always sum to 1. So what I need to do is take that 0.40, take the 0.25, take the 0.15, add them together. It is a calculator paper, remember. That will give you 0.8. And then I can do 1, take away that 0.8, leaves me with 0.2. And that's my final answer. So for this, you get 1 mark for showing that you know to add all the probabilities together, and the second mark for the answer. You also get a mark if you've shown 1 take away 0.8, because that indicates that you have added the other probabilities up. The second part, Dinesh takes at random a disc from the bag. He writes down the colour of the disc, he puts the disc back into the bag. He will do this 60 times. Work out an estimate for the number of times he takes a red disc from the bag. So I'm looking for the probability of red, which is 0.4. So we want to find a probability of 0.4 of, which is times, 60. So we've got 0.4 times 60, which equals 24. So 24 times he takes a red disc from the bag. Now for this, you get 1 mark for showing you know to multiply them together, and you get the second mark for the final answer. Question 2 is a ratio question. A pile of sand has a weight of 60 kilograms. The sand is put into a small bag, medium bag and a large bag in the ratio of 2 to 3 to 7. Now the way ratios are always set up is the order they're given in the question is the order of the ratio. So that is small, that is medium and that is a large bag. Work out the weight of sand in each bag. So first thing you do here is you work the total number of parts you've got. So you add those together. So 2 plus 3 plus 7, and that ends up giving you 12. So I got 12 parts all together. Now I need to take the 60 kilograms divided by that 12 parts, and 60 divided by 12 gives me 5 kilograms, and that is what 1 part is worth. Then I need to say, well, if in the small bag there are 2 parts and 1 part is worth 5, I can say that the small bag has got 5 times 2 in it, which is 10 kilograms. The medium bag has 3 lots of 5 in it, which is 15 kilograms. And the large bag has 7 lots of 5 in it, which is 35 kilograms. So that's 10 small, 15 medium, 35 large. With regards to the mark allocation, you get 1 mark for showing 60 divided by whatever your total number of parts is. You get another mark for indicating that you've times it by at least one of the ratios. And then you get the final mark for having the correct answer. If you've only got 2 of these measurements correct, then you can get 2 marks in total, not the full 3. Question 3 looks like an algebra question, but it's really a question about your understanding of the mean hidden in some algebra. So Julie is X years old, Kevin is X plus 3 years old, Omar is 2X years old. Write an expression in terms of X for the mean of their ages. Now they only want an expression, they don't want anything equal to anything, they don't want to work out the actual ages. We just need to know how to find the mean. Now the mean is where you add them all up and you divide by the number you have. So how many people have we got? Well, we've got 3 people. So Julie's age is X. Kevin's age is X plus 3. Add Omar's age, which is 2X. So I've added them all up and I divide by 3. Now I could go ahead there and say X and X and 2X is 4X plus 3, but they haven't asked me to simplify it, so for now that is actually going to do. With regards to the mark scheme, you get 1 mark for showing that you've understood the need to add them together, and then you get the 2nd mark for showing that you've added them together and divided by 3. Question 4 is a questionnaire question. James wants to find out how long his friends spend using the internet. He uses this question on his questionnaire. How many hours do you spend using the internet? 1 to 5, 5 to 10, 10 to 20. Write down 2 things that are wrong with this question. Now, there are 3 things that are wrong with this question. They've only asked for 2 in the paper. I will tell you the 3. So the first one that should jump out of you always, or jump out at you even, is the time frame. There's no time frame in this question. It just says how many hours do you spend using the internet. That could mean in a day, a week, a month, a year, 10 years. It doesn't say. So that makes the question unreliable. So it's missing a time frame. The second thing it's doing is if I did spend 5 hours using the internet, which box would I tick? That one or that one? It's not clear. The reason it's not clear is because there's a 5 for both boxes. So this is called overlapping boxes. Now the third aspect is less obvious, and it's the fact that the boxes are not exhaustive. And what we mean by not exhaustive, there's a H in there, sorry. What we mean by not exhaustive is the fact that it doesn't cover all possibilities. What if, like my dad, you don't use the internet? What box is he going to tick? Nothing. There's nothing there for him to tick. What if I'm on the Xbox all the hours God sends, and so I spend about 50 hours? There's not an option for me there. So there should be a more than box or a none box. Well, it's a 2-mark question, and you get 1 mark for each aspect, and you only needed to provide 2. Write a better question for James to use on his questionnaire to find out how long his friends spend using the internet. So really here, you're getting double the marks for knowing the same piece of information. My question needs to include a time frame, and my boxes had better not be overlapping. So I can use the exact same question he's used above, because that looks lovely. How many hours do you spend using the internet? But I'm just going to add on the end in a week. So how many hours do you spend using the internet in a week? So there's 1 mark, and then I'm going to give some response boxes, and that one's going to be for 0, don't use the internet. That's going to be 1 to 4 hours. That's going to be 5 to 9 hours. And that's going to be 10 hours plus. So they're not overlapping, and it's very clear which box you can tick. So that's a 2-mark question. You get 1 mark for mentioning the time frame, 1 mark for getting the response boxes correct. Question 5 is a scattergraph question. Scattergraph shows information about 8 people. It shows each person's height and the circumference of their head. Height, circumference of head. And if you look at the scales, that goes up every 10 squares. It goes up by 10 centimetres. So that's nice. It means each little square is 1. And the same up the side. Each little square is 1. So this is a nice, easy scattergraph for us. The table gives the information for 2 other people. This person with a height of 180 and a circumference of 72, and this person with a height of 170 and a circumference of 65. On the scattergraph, plot the information from the table. So I've got 180 and up 72, So there's 180 to, oh, I'm stuck, to 72. And then 170 to 65. 170 is there, up to 65, which is there. Then part B says describe the correlation. Well, it's uphill, so it is positive correlation. Positive correlation. Draw the line of best fit on your scatter graph. So my line of best fit is a line that goes through the middle of the points. It doesn't have to be perfect, but it has to be pretty accurate. So I'm going to do my line of best fit. There, perhaps. So there's my line of best fit. And then part D asks us to estimate. And the fact that it's asking us to estimate means they want us to use the graph. Estimate the circumference of the head of a person who is 156 centimetres tall. So there's 155, 156, which is there. I'm going to show it on my graph. I'm not going to make the mistake of simply looking up and reading where I think. If you haven't used the graph, you cannot get the mark for using the graph. And mine comes out just at 54. So mine is 54 centimetres. However, the mark scheme will allow you anywhere from 52 up to 60. And it's quite a big range because people draw their lines of best fit differently. So they're all 1 mark questions. Question 6 is a best value question where we can use the unitary method pretty nicely. So dishwasher tablets are sold in 2 sizes of box, small boxes and large boxes. A small box contains 15 tablets and costs £3.95. A large box has 22 tablets and costs £6.15. Which size of box gives the better value for money? You must show all your work in. So it's asking you which box. So at the end you need to make sure you make your conclusion. Now in order to do unitary method, it's all about finding out what 1 unit is worth. So here, because they're asking for a comparison, I'm going to be comparing small and large boxes. So in a small box, I get 15 tabs for £3.95. And in a large box, I get 22 tabs, and that costs me £6.15. Now, in order to find out how much 1 tablet costs me in the small box, I need to take my £3.95 divided by the 15 tablets that are in the box. It's a calculator paper, and 3.95 divided by 15 is 0.263. Now, you might be thinking, 0.263, don't be ridiculous, that's not money. Well, remember, we're working in pence here, so what that actually is 26 pence. Okay, so it's 26 pence for 1 tablet in the small box. In the large box, 1 tablet is £6.15 divided by 22. And 6.15 divided by 22 is 0.279. And again, remember, it's money. So the 9 would round my 7 up to an 8, and that would be 28 pence. So a small box is 26 pence for 1 tablet, and a large box is 28 pence for 1 tablet. Based on that, I can write my conclusion, and I can say that the small box is the better value for money. And with regards to marks for this, it's pretty generous. You get 1 mark for showing you can work out the cost of 1 tablet of the small. You get another mark for showing that you can work out the cost of 1 tablet in the large. So really you're getting 2 marks there for only knowing how to do 1 thing. you get the answer mark for indicating that that is the price that's the lowest and reaching two comparable prices. And then you get the fourth mark, which is a communication mark, and that is for very clearly answering their question. Now part B is a minimum and maximum upper and lower bounds question. The weight of a large box is 357 grams to the nearest gram. What is the minimum possible weight for the box? What is the maximum? Now if anything asks you for the minimum and maximum, all you need to do is take away 0.5 of a unit, in this case grams, to find the minimum, or add 0.5 of a unit, remember the units are grams, to find the maximum weight. So the minimal possible weight is 357, take away half a unit. So what you're left with is 356.5. And for the maximum, you take your 357 and you add 0.5 of a gram, and that's going to give you 357.5. So they really are pretty simple questions once you know how to do them. 1 mark each. Question 7 is a distance time graph question. The graph shows the distance travelled by 2 trains. Distance travelled and time it takes them to travel. Train A, train B. Work out the gradient of the line for train A. Gradient equals the rise over run, otherwise known as the change in the y-axis divided by the change in the x-axis. In order to do this, you find 2 points where the line for train A crosses over whole number values. So I'm going to pick that point there because it crosses exactly on the 25 and the 50, and I'm going to pick that point there, and I'm just going to draw a little right angle triangle on them. So the rise, the distance in the height there, is from 40 to 50, so it's 10, and it's got a run, a distance in x, from 20 to 25. So it's got a run of 5. So my gradient is going to be 10 over 5. 10 divided by 5 is 2. So the gradient is 2. Part B then asks, which train is travelling at the greatest speed? You must explain your answer. So looking at the graph, we can see, and we can offer any kind of an explanation. The mark scheme offers loads of options, but I'm just going to go simply for the fact that in 30 minutes, train A has travelled a greater distance because the speed is constant. We know that because it's a straight line. So within 30 minutes, train A's gone faster or gone further than train B. So that's going to be my explanation. You could go ahead if you wanted to and try and work out the gradient of train B because it'll be less than 2. So go ahead and do that if you want. You can make the right angle triangle maybe from there to, oh, well, we'd go there. There's a whole point to there. And we could say it's got a height of 40, a rise of 40 and a run of 30. And I could say, well, line B, train B, would be 40 over 30. I could put that in a calculator and it would give me 1.3 or so. So there I can see my gradient is less. But either way, the answer is train A is faster because it covers a greater distance than train B in the same amount of time. Part C asks, after how many minutes has train A gone 10 miles further than train B? So I'm going to look at my graph and I'm going to look at the difference this time between train A and B. So here they're both at a distance of 0. Here it's small but not quite 10. At this point, train A has travelled 10 miles and train B has travelled what looks like 6 miles. So no, that's a difference of 4. Here, no. Here, well, train A has travelled 20 miles and train B has travelled more than 10, so that's no good. Here, no. Here, train A has travelled 30 miles and train B has travelled 20 miles, so jackpot. That's where my distance is 10. So I can say that happened at 15 minutes. So after how many minutes? 15 minutes. And that's 1 mark.